Hey guys, welcome to mathspays.com, looking at right-angled trigonometry, predominantly finding sides using the rule Sokotoa, but a bit of introduction as well. Hopefully you've had a little bit of a look at some of the previous videos about where trigonometry has come from and what it's all about, I guess. In short, we're looking at finding sides at angles, okay, angles of triangles. Of course, you can look at any triangles. We're looking predominantly at right-angled trig. Okay, it's been around for many centuries. Okay, and it's had a lot of contributions from a lot of different people and civilizations. First started up by the Greeks, I believe, and then certainly had contributions from the Babylonians, from the Egyptians and their pyramids, from the Indians, and of course the Muslims had a real great impact later on, and really were the first ones using right-angled trig. Trigonometry, the angles when they first began, it was all about a circle, okay, and looked about the ratio or the radius versus the circumference and all sorts of different things. But certainly that's kind of our high level mathematics. What we're looking at is the easiest stuff, I guess, which is looking at angles within the right angles, okay, and I guess that's using things called degrees as opposed from things called radians, both measurements of angles, but this is the guy that we're looking at today and probably for the next few years at least. So trigonometry, one of the most important aspects of trig that you need to get used to is being able to label the sides of a triangle, okay, and think it is called trig because it's about triangles, right? Now if I look at a right angled triangle, because that's what we're looking at the moment, we will hopefully remember that the longest side of a triangle is called the hypotenuse, okay? That never changes in any of the questions. It's always opposite the right angle, okay? But what does change is the two other sides. So the first one we know is called the hypotenuse, but the second and third is called the opposite side and the adjacent side. Now it is all dependent on the angle that is drawn into my particular triangle. Now of course it could be like 60 degrees or 20 degrees or 110 degrees. Actually it can't be 110 degrees because the right angled triangle is going to be less than 90. But what we often use is this little symbol here. Now you may or may not know this one. This is called theta. All right, it's a Greek symbol that we use to represent an angle. Okay, a little bit like we use algebra, like x's and y's, but we use the Greek symbol theta to do that. We sometimes might even use this one, okay, and that's called alpha. And that's if we need to speak about more than one or talk about more than one angle. So in regards to theta, the side that is opposite the theta is, surprise, surprise, called the opposite. The side that is next to the angle theta is what we refer to as the adjacent side. All right, because it's next to. Adjacent means next to. So what they worked out many years ago are the following: that if we looked at the angle where, let's say, theta is there, if we look at sine theta, that is the exact value or exact same value as now sine is s, the opposite over the hypotenuse sine. Okay, if I look at cos, all right, cos theta, we say that's the exact same value as looking at the adjacent side over the hypotenuse side. What do you reckon TOA might be? Okay, that is tan theta equals the opposite side over the adjacent side. And what you might notice is that sine, cos and tan are all buttons that are on your calculator. Okay, so if you know at least two pieces of information, so that kind of means if I know what the angle is and I know what, let's say, the opposite side is, then what we can do is rearrange it to find the hypotenuse. Or if we have the angle and we have the hypotenuse, we can rearrange it to find the adjacent. In fact, if we know what the opposite and the adjacent side is, we can rearrange it to find what tan theta is or what theta is. But look, we're focusing on just sides today. So let's jump into it. What we really need to know is how to do the questions, right? That's what you're here for. So we've got the first question. I'm going to go through it with you, and then you can have a crack at the next two. They'll get progressively more challenging, but they're pretty straightforward today. Okay, so the first step you need to always make sure, as I mentioned in that last sort of page, was that you need to label the sides. Now, what I like to do is just label the sides that are given. So, for example, we have the x here. Well, the x is opposite to where the 50 degrees is, so it's called the opposite side. The 6 centimeters is next to the 50 degrees, so we call that the adjacent side. If I just label those two, then I have O and A. All I need to do now is simply go up into my 3 rules, SOHCAHTOA, and remembering that S means sine, C means cos, T means tan. The O, H, and the A are simply those labelings that we spoke about. Then there's only one side, or one of my rules here, that has the O and the A, and that is the TOA rule. Okay, so that TOA rule is important. So TOA is tan theta, because it's always tan and the angle, equals the opposite over and the adjacent side. Now, it is not a bad idea to write that rule out each time, just when you're first starting out with trigonometry. But the main part of your marks are going to first come from substituting the values. Now, the theta we know to be the unknown angle. In this case, it's known. It's 50 degrees. And then the opposite side is the x, and the adjacent side is the 6 centimeters. So what I've come up with now is actually an equation, because we want to solve it to find out what x is equal to. So if I want to isolate just the x by itself, that means I want to get rid of the divided by 6. Well, the opposite of divide by 6 is times by 6. So we can say x is equal to 6 times tan 50. Now what we can then do is grab our calculator out, make sure that it is in the degrees mode. It should have a little D at the top of your calculator, otherwise it won't calculate it correctly. And we're going to type in 6 times tan of 50. You don't have to even put the degree sign. You can put the degrees if you want it there, but we don't have to. And it comes up with 7.15, okay, centimeters, and that is to 2 decimal places. There will be some times we get exact numbers or whole numbers, but most of the time, guys, you will have to round. Okay, so where do your marks come from? This is a 2-mark question. The first mark comes from that first line of working. The second mark will come from your answer. Okay, that's the first example. Now, the second example, I want you to have a go at this on your own. Okay, very similar, just using a different rule. First of all, label it and then go from there. Okay, welcome back, guys. So did you label it correctly? Okay, so remember, to label the diagram, we've got the 70 degrees. The x is next to the 70, which means it is the adjacent side. And the 15 centimeters is opposite the right angle, which actually means it is the hypotenuse. So we're using the adjacent and the hypotenuse, which means that we're using the cos rule, okay, or CAH. So for my working out, for my first mark, I've got cos my 70 degrees, that's my cos theta, equals my adjacent, which is x, over my hypotenuse, which is 15. So it's very similar to that last question, yet we're using cos instead of sine. I can then cross the divided by 15 out, and I'm going to do times by 15. Okay, that's my second part of my working out. So I've got x equals 15 times cos 70. You don't really need to have that line of working in, but certainly it's not a bad idea when you first start off. Now I'm going to simply get my calculator and type in 15 times cos of 70. I'm going to press equals. In this case, to 2 decimal places, we get 5.13 centimeters, or I guess 5.1 to 1 decimal place, but I've done it to 2. All right, again, pretty straightforward. The next one, the start is the same, but the algebra is going to be a little bit more challenging. I want you to have a go at it. Okay, how'd you get on, guys? So, first step, like all the other ones have been, the first step is to label. Okay, I really want you to do that each time. So, in terms of the 40 degrees, we've got the 6 centimeters, which is the opposite side, because it's opposite the 40. And the x is our hypotenuse, because it is opposite the right angle. So we're looking at O and H, which you might recognize as the SOH, so, or sine rule. So let's go through. I've got sine theta. We know what theta is. Theta is 40 degrees. We've got our opposite, which is 6. And we've got our hypotenuse, which is x. Now, that's our first mark, and I wonder if you can recognize why this is a bit more challenging. In the past, we've had a number on the bottom, and we've simply said the opposite of divided by the number is times by the number. The problem is this isn't a number, this is our letter. But we're going to do the same method. Okay, the opposite of divide by x is times by x. All right. The issue is what I've now got is x times sine 40 is equal to 6. We don't have the x equals. Okay, so it's not just as straightforward, but it isn't too much more challenging because the opposite of times sine 40, yep, you got it, is divided by sine 40. Okay, or you can put it as a fraction if you wish, like that. Now, of course, I can put that into my calculator nice and easily and do 6 divided by, or 6 over, sine 40, whichever key you wish to use, and we come out with the answer of 9.33 centimeters to 2 decimal places. Another thing that you'll notice, and you get used to this, right, that at the beginning of that question, we had sine 40 equals 6 over x. And our last set of working, we had x equals 6 over sine 40. Do you notice anything? There's something that's kind of happened. And you can kind of learn a quick little rule. If the letter is on the bottom, what you can actually do, you can simply swap them around. Okay, it works every time. Again, the reason for that is because you're timesing by the x, and then you're dividing by the sine 40. So it actually just works out. If you remember it, that's awesome. Otherwise, just do that double step, times by the x, divide by the trigonometry term, and then you can put it into your calculator to get the 9.33 in this particular case. Look, guys, that is trigonometry. One of the most important things to start with is that you need to learn that rule. Okay, so katoa. There's a lot of videos on YouTube about the songs, try and get that into your head. There are in year 10, 11, and 12 formula sheets that have that information on, but really, guys, that rule is pretty critical that you should know it off by heart. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, tan equals opposite over adjacent. That is right-angled trigonometry, finding sides in a nutshell. Practice some questions, any problems, drop me an email. Otherwise, guys, have an awesome day.